In the realm of science, the unexpected often leads to the most profound discoveries. It's in these moments of surprise and mystery that scientists find the greatest opportunities to expand our understanding of the world. The pursuit of knowledge is often a journey into the unknown, where each new discovery can challenge our preconceived notions and push the boundaries of what we know. In mid-September 2023, a mysterious tremor rippled across the Earth, lasting for 9 days and baffling scientists worldwide. This was no ordinary seismic event. It was something that defied conventional explanations and left experts scratching their heads. The tremor's persistence and global reach made it a phenomenon that could not be easily dismissed or ignored. Initially dubbed an Unidentified Seismic Object (USO), this enigmatic event sparked a wave of speculation and theories. Researchers from various fields came together, pooling their expertise in an attempt to make sense of the data. Theories ranged from the plausible to the fantastical, each one adding a piece to the puzzle but none providing a complete picture. Some attributed it to faulty instruments, while others suspected volcanic activity. The possibility of a malfunction in the equipment was considered, but the consistency of the readings across different locations suggested otherwise. Volcanic activity was another potential cause, yet there were no signs of eruptions that could account for the tremor's unique characteristics. The scientific community was in a state of heightened alert, eager to decipher the source of this global tremor. Meetings were held, data was scrutinized, and hypotheses were tested. The urgency of the situation brought together some of the brightest minds in the field, all united by a common goal: to solve the mystery of the 9-day tremor. The Earth, our seemingly solid planet, is in a constant state of motion. Beneath our feet, tectonic plates shift and collide, shaping the landscape over millennia. This dynamic nature of our planet is a reminder of the powerful forces at work, forces that can sometimes manifest in unexpected ways. Plate tectonics, volcanic eruptions, and even the impact of meteorites all contribute to the planet's dynamic nature. These events, while often destructive, are also a testament to the ever-changing and evolving nature of Earth. They remind us that our planet is not a static entity but a living, breathing system. However, this particular tremor was unlike anything recorded before. Its characteristics did not match any known seismic activity, making it a unique and perplexing event. The data collected was both intriguing and confounding, presenting a challenge that required innovative thinking and collaboration. Its duration and global reach were unprecedented, challenging our understanding of Earth's inner workings. The tremor's ability to persist for 9 days and be detected across the globe suggested a phenomenon of immense scale and complexity. It was a puzzle that demanded a deeper investigation into the forces shaping our planet. The scientific community, armed with advanced technology and a thirst for knowledge, embarked on a quest to unravel the mystery of the 9-day tremor. Utilizing cutting-edge tools and techniques, researchers delved into the data, seeking clues that could explain this extraordinary event. Their journey took them to various corners of the globe, each step bringing them closer to understanding the tremor's origin. Little did they know that this investigation would lead them to the icy glaciers of Greenland and expose a stark warning about the escalating impact of climate change. The findings revealed a connection between the tremor and the melting ice, highlighting the profound and far-reaching effects of a warming planet. This discovery underscored the urgency of addressing climate change and its potential to trigger unforeseen and widespread consequences. High in the Arctic, where ice reigns supreme, lies a world of stark beauty and harsh realities. This is a place where the forces of nature are both magnificent and merciless, sculpting the landscape over millennia. On September 16, 2023, a dramatic event unfolded that would capture the world's attention and highlight the urgent need for climate action. A massive glacier in eastern Greenland, weakened by the relentless advance of climate change, finally succumbed to the inexorable forces of nature. This glacier, a giant of ice, had stood for thousands of years, a testament to the Earth's climatic history. The glacier, a colossal river of ice that had flowed for millennia, fractured and gave way, triggering a cataclysmic chain of events. The sound of the ice breaking apart echoed through the frozen landscape, a stark reminder of the power of natural forces. Climate change, driven by human activities such as industrial pollution and deforestation, has been steadily warming the planet. The Arctic region, in particular, has experienced the most dramatic temperature increases, with consequences that are both profound and far-reaching. This accelerated warming has had a profound impact on glaciers worldwide, causing them to melt at an alarming rate. The retreat of these glaciers is not just a loss of ice but a loss of history, as each glacier holds within it a record of past climates. The Greenland ice sheet, one of the largest ice bodies on Earth, has been particularly vulnerable to this warming trend. Covering roughly 1.7 million square kilometers, it holds enough ice to raise global sea levels by over 7 meters if it were to melt completely. As temperatures rose, the glacier in eastern Greenland began to melt at an accelerated pace. The once solid ice turned to water flowing in rivulets and streams across the glacier's surface. Meltwater seeped into cracks and crevices, further weakening the ice structure. This process, known as hydrofracturing, can rapidly destabilize a glacier, making it more susceptible to breaking apart. The once mighty glacier, now precariously balanced, was on the verge of collapse. Its fate serves as a stark warning of the impacts of climate change and the urgent need for global action to protect our planet's fragile ice landscapes. The inevitable finally occurred on that fateful day in September. With a thunderous roar that echoed across the frozen landscape, a massive chunk of the glacier, a 500-foot-thick slab of metamorphic rock, 1.2 kilometers high, broke free and plunged into the depths of the fjord below. The sheer scale of the event was staggering, a testament to the immense power of nature unleashed. The volume of rock and ice involved in the landslide was colossal, equivalent to 10,000 Olympic-sized swimming pools. This massive chunk of earth and ice plummeted into the fjord at speeds reaching 47 meters per second or 160 kilometers per hour, displacing an enormous volume of water. The impact of the landslide reverberated throughout the surrounding region, sending shockwaves through the Earth's crust. The once tranquil fjord was transformed into a cauldron of churning water and debris, a visible manifestation of the forces unleashed by the glacier's collapse. The sudden displacement of such a massive volume of water generated a mega-tsunami, a towering wall of water that surged outward from the impact site with terrifying speed and force. Initial waves reached a staggering height of 650 feet, dwarfing even the largest tsunamis recorded in human history. The Mega-Tsunami, though gradually losing its initial monstrous height as it traveled outward, still packed a devastating punch. Coastal areas were inundated by the surging water, causing widespread damage and destruction. An unoccupied research station on Ella Island, 72 kilometers away, bore the brunt of the tsunami's fury, sustaining significant damage. A centuries-old heritage site, a trapper hut that had stood as a testament to human resilience in the face of nature's challenges, was swept away by the relentless waves. The tsunami's impact served as a stark reminder of the vulnerability of human infrastructure in the face of such catastrophic events. Section 5. A persistent hum. While the mega-tsunami subsided, leaving a trail of destruction in its wake, the landscape was forever altered. Entire communities were displaced, and the natural environment was reshaped in ways that would take years if not decades to recover. The immediate aftermath was a scene of chaos and despair, with rescue operations struggling to reach the most affected areas. The seismic consequences of the glacier collapse were far from over. The initial impact had set off a chain reaction of geological events, each more unpredictable than the last. The collapse had not only triggered the tsunami but had also destabilized the surrounding area, making it prone to further seismic activity. The impact had triggered a strange and persistent phenomenon in the fjord, a seiche. This standing wave, caused by the sudden displacement of water, began to oscillate within the confines of the fjord, creating a rhythmic motion that was both mesmerizing and ominous. This standing wave, oscillating back and forth within the confines of the fjord, created a unique pattern of movement. The water seemed to have a life of its own, moving in a way that defied the usual expectations of wave behavior. It was as if the fjord had become a giant natural metronome. The oscillations generated seismic waves that resonated throughout the Earth's crust. These waves traveled far and wide, carrying the signature of the seiche to distant corners of the globe. The energy released was enough to be detected by sensitive instruments, even if it was imperceptible to human senses. The seiche, peaking every 92 seconds, acted like a giant metronome, sending out a steady pulse of seismic energy. This regularity was both fascinating and unsettling, as it suggested a level of predictability in an otherwise chaotic natural event. The steady pulse of seismic energy acted like a heartbeat for the fjord, a rhythmic reminder of the forces at play beneath the surface. This pulse was picked up by seismographs around the world, creating a global network of data points that scientists could analyze. These waves, though too faint to be felt by humans, were detected by sensitive seismographs around the world. The instruments recorded the subtle vibrations, adding them to a growing body of data that would help scientists understand the event. The data collected from these seismographs created a detailed picture of the event, allowing scientists to piece together the sequence of events that had led to the persistent 9-day tremor that had puzzled scientists. This tremor was unlike anything they had seen before, a continuous hum that defied easy explanation. The persistent 9-day tremor had puzzled scientists, leading to intense discussions and debates. The data was scrutinized, hypotheses were formed and tested, and slowly, a clearer picture began to emerge. The Seiche was the key to understanding this mysterious phenomenon. The Seiche's wave height, initially quite significant, gradually decayed over time. As the energy dissipated, the oscillations became less pronounced, and the fjord began to return to a state of relative calm. However, the effects of the Seiche were still being felt, even as the visible signs faded. After 3 days, it had diminished to the point where it was no longer visually observable, even by the Danish Navy, which had been monitoring the region. The Navy's observations were crucial in understanding the full impact of the Seiche and its eventual dissipation. The Danish Navy, equipped with advanced monitoring equipment, had been keeping a close eye on the fjord. Their data provided valuable insights into the behavior of the Seiche and its gradual decline. Even as the visible waves disappeared, the seismic signature remained. However, the Seiche's seismic signature continued to reverberate around the globe. The faint but persistent waves traveled through the Earth's crust, a lasting reminder of the powerful forces that had been unleashed. This global reverberation was a testament to the interconnectedness of our planet's geological systems. In our quest to understand the planet, we often find ourselves unraveling mysteries that have puzzled humanity for centuries. Each discovery brings us closer to a deeper, more profound understanding of the world we inhabit. And with every answer, new questions emerge, driving us to explore even further. Everywhere we look, we can see the fingerprints of climate. From the shifting patterns of weather to the changing landscapes, climate leaves its mark on everything. The evidence is all around us, waiting to be uncovered and understood. It's a story written in the very fabric of our environment, one that speaks to the intricate balance of nature. The past echoes through time, leaving clues and traces that help us piece together the history of our planet. By studying these echoes, we gain insights into the forces that have shaped our world. It's like listening to a conversation that has been going on for millions of years, a dialogue between the Earth and its inhabitants. As we uncover these stories, we are faced with a call to action. The knowledge we gain is not just for understanding, but for making a difference. It's a reminder that we are stewards of this planet, responsible for its future. Every step we take, every choice we make, can contribute to a better, more sustainable world. Let's answer this call with determination and hope.